All right, today we're taking notes over composite polygon and their perimeter. These are our notes. Okay. The polygon table we did in class, if you were absent, you'll want to go back and get that done on your own. Okay, so we're going to define quite a few things here. First, lines. Parallel lines are lines that are always the same distance apart. So, never cross. All right, some real world examples would be like fence posts, bookshelves would never cross. They'd be parallel to each other. Snow skis. Okay, so they're the same distance apart, two lines, and we write them kind of at an angle like that when we abbreviate parallel. Okay, next, intersecting lines. Two lines that will eventually cross each other. They don't have to be crossing yet, but eventually they would. Some examples I want you to write down would be like scissors. Definitely cross. And many roads, not all roads, but most roads will eventually cross. So if I have two lines that haven't crossed yet, like the two I've drawn there, eventually, if we extended them out, right now they're just line segments, eventually they would cross. Okay, our next word is perpendicular lines. Two lines that intersect to form right angles. And these are intersecting for sure. Okay, so the most common example would be any corner, most all corners. They are right angles. Okay, yes, they're intersecting too. Some letters would be like the capital letter T has some right angles in it, capital letter H, and capital letter L, obviously. Right there looks like a corner. All right, so that's background about the word lines. Let's look at polygons now. A polygon is a closed figure with three or more, can't be two straight sides. Okay, if it's only two, it'll just be an angle. So you need three or more straight sides. A circle is not a polygon because it has curved sides. Regular polygons then are all sides are the same length for it to be regular. Examples would be not all triangles, but we call them equilateral triangles. Not all quadrilaterals, not rectangles, but specifically squares would be the four-sided. And a five-sided we would call not all pentagons, but a regular pentagon. Okay. So these are going to have all five sides are the same length, and all five angles would be the same too. Same thing with squares and equilateral triangles. I should probably regular pentagons. All right, next for congruent pentagons or polygons are two polygons with the same side lengths and the same angles. Not all the angles have to be the same, but if we have two congruent polygons, like this picture I have here, angle A is the same as angle F, angle B is the same as angle G, H is the same as C, okay? Line segment ED is the same length as line segment JI. So they look identical. They look the same. Even though they have different letters, they look identical. You can put on top of each other, okay? And they would fit exactly the same. Those are congruent polygons. You can rotate them. So even if you rotate it a little bit, that doesn't stop them from being, pretend that's the same. Even though it's rotated, they can still be congruent. Okay, so now, conversely, similar polygons do have the same shape, meaning they have the same angles, but they're going to be different sizes. Okay, so looking at my picture over here, line DA is similar to EH, or but they're different sizes. Or angle D here is the same as angle H, but again, different sizes. Okay, that's what makes them similar. All right, let's move on to today's meat, composite polygons. Composite polygons are shapes that can be divided into two or more simple polygons. So the word composite means we're combining at least two things. Okay, so find the missing side lengths. Now we're going to deal with perimeter stuff. To find missing side lengths, we need to find all the parallel sides. So we'll do it with this example down here before, and I would like you to draw this. So let's find B. I'm going to do it in blue. So we find the other sides that are parallel to B. We have 10 here, and we have 15 here. Those are all parallel. I'm going to draw it over here. There's my 15. There's my 10. There's B. Now we're going to see how they relate. Well, clearly 15 is the longest here. This 15 is the same as this 10 line plus this B line. All I got to do is move it over. So 10 plus B is the same as 15. So what's B? B is going to be 5. Because if we look back at our original, 5 plus 10 is the same as 15. All right. Let's do the same to find A. There's A. What's 8 and 7 are parallel to that. So if we look at how long A is the same as this 8 plus this 7. If I move this 7 down here, you'll see that this 7 and 8 is the same as A. So A is going to be 15. All right, look over off to the side here. We're going to do the same thing to find X. Okay, so first find what's parallel to X. That 8 foot and that 15 foot. And so 15 foot's clearly the longest. We can move X over here, and we can see that X plus 8 is 15, so X is going to be 7 feet. Same thing for Y. Y plus 6 is going to be 11, so Y has to be 5. 5 feet plus 6 feet is 11 feet. Sometimes the composite polygons will have more sides than that, and you might have to add more to find it out. Okay, so that is how we find missing side lengths. So now let's find the whole perimeter of this next shape. The first thing you want to do is find all the unwritten sides. Okay, so we can see if we look at all the sides of this shape, so far we have 4 plus 4 plus 3 plus 5 plus 3 plus 4 plus 4 plus this long one. Okay, so we need to find that missing side length like we did above. So to find this long side length, we have to find what's parallel to it. 4 plus 5 plus 4. It's not just 2 numbers, it's 3 numbers this time. That distance is 5. Those are the same. So 4 plus 5 is 9, plus 4 more is 13 inches. Okay, so now to find the perimeter, we need to add them all together. And for this one, I'm going to have you write it off to the side. I like to just start with one length and just add going around. I usually start with the longest. There are shortcuts, which I can show you in class. But this one time, let's write it all out. So we're going to add those. So 13 plus 4 is 17, 21, 24, 29, 32, 37, 41. Ooh, I think I messed up. Let me back up. 17, 21, 24, 29, 32, 36, 40. My answer should be 40 inches. How did I know I messed up the first time? I said 39. You don't have to write that in your notes. Well, because it's odd. And because I know when I was adding, it's going to end up even. Here's a shortcut for it. I'll just tell you it. I won't really show you how this time. But if this line here is 13, then these three are going to add up to 13. So 13 times 2 is 26. If on my left side here I have 4 plus 3, which is 7, these other two are going to add up to 7. So that's another 14. So my answer is 50. What? No, my answer is 40. 40 inches. Okay, thanks. That was a shortcut. I'm not going to really explain that to you today. Feel free to work it out that way in the future. Okay, here's some of the topics you can do. Good luck.